A warm greetings to one and all. In this session, let's start learning about data types and type modifiers in C++. Topics to be covered in today's session are Introduction to data types in C++, type modifiers in C++, and finally, let's check out few example programs. Introduction. Yes, we all know that the data types are fundamental concepts in programming. They define the type of data that can be stored in a variable. C++ data types are normally categorized into three types, namely fundamental data type, derived data type, and user-defined data types. So fundamental data type is also called as primary or primitive or built-in data types. C++ has extensive support for primary data types. They are defined in C++ itself, so they are called as built-in data types. Example, integer, float, character, and etc. Derived data types. They are derived from primitive or built-in data types. Example, function, array, pointers, and references. User-defined data types. They provide mechanism that allows user to define their own data types. Example, class, structure, union, enum, and typedef. Primitive data types in C++. Integer data type. They store integer value, which are whole numbers without decimal values. The size utilized is 2 bytes and the keyword is int. Character data types store a single character, alphabet, numbers, or symbols. Size utilized is 1 byte and the keyword used is char. Boolean data type stores the value either true or false, which is represented by 1 or 0. Size utilized is 1 byte and the keyword used is bool. Floating point. It stores single precision decimal values. Size utilized is 4 bytes and the keyword used is float. Double floating point. It stores double precision decimal values. Size utilized is 8 bytes and the keyword used is double. White character. It takes up twice as much space as char. Size utilized is 4 byte and the keyword used is wchar underscore t. Void. No value or nothing used in function which does not return any value. So size utilized is 2 bytes and the keyword used is void. In this example program, we can learn how to declare and assign the values to primitive data types. Here, the variable a is declared as int with value 5. The variable b is declared as float with value 5.99. The variable c is declared as double with value 9.98. The variable d is declared as char with value capital D. The variable e is declared as bool with value true. The variable f is declared as bool with value false. The variable g is declared as wchar underscore t with value small d prefixing capital L. Using cout statement, the values of the variables a, b, c, and d are displayed to the users. The internal representation of Boolean value true is 1. Therefore, the variable e is displayed as 1. Similarly, the internal representation of Boolean value false is 0. Therefore, the variable f is displayed as 0 to the users. Wcout statement is used to display the variable g, which is varchar data type. It prints the value small d as such. But if we use cout instead of wcout statement, the ASCII value of small d is printed, which is 100 for g variable. Type modifiers in C++. A modifier is used to alter the meaning of the base data type so that it more preciously fits the need of various situations. C++ allows the int, char, and double data types to have modifiers preceding them. There are 4 types of modifiers in C++ programming language. They are signed, unsigned, long, and short. Signed and unsigned type modifiers utilizes 4 bytes of memory spaces. Long modifier utilizes 8 bytes of memory space, and short modifier utilizes 2 bytes of memory space. Type modifiers for int. Int data type utilizes 2 bytes of memory space. That is, it needs 16 bits to store the values. Let's check out the node to calculate the range values. We can get the size of data types in bytes. So we can simply multiply them into 8 to get the values in bits. Now we know that if the number of bits are n, then the minimum range will be minus 2 to the power of n minus 1 and the maximum range will be 2 to the power of n minus 1 minus 1 for signed numbers. For unsigned numbers, it will be 2 to the power of n minus 1 as there are no negative numbers. Let's check this calculation for integer data type. So the range calculation for integer data type. It is signed number, so it requires 2 bytes of memory space. That is 16 bits is required to store a value. The minimum range to represent the negative numbers is calculated using the formula minus 2 to the power of n minus 1. The n value is 16, so we can substitute here. Therefore, minus 2 to the power of 16 minus 1, that is minus 2 to the power of 15. The value is minus 32,768. Therefore, the minimum range represents from minus 32,768 to minus 1. Next, maximum range to represent the positive numbers. The formula used is 2 to the power of n minus 1 minus 1. We can substitute the n value, that is 16. So 2 to the power of 16 minus 1 minus 1. So 2 to the power of 15 minus 1. The value was 32,767. So the positive numbers are represented from 0 to 32,767. So that is what the range value which is being given here. So from negative to positive, that is minus 32,768 to the positive number, that is 32,767. Next, signed int. Signed int also utilizes 2 bytes of memory space, that is it requires 16 bits to store a value. So the range calculation is similar to integer data type. Next, unsigned integer. It utilizes 2 bytes of memory space, that is it needs 16 bits to store the value. Now let's check the range calculation for unsigned int. Since there is no negative numbers, the formula to calculate the range calculation for unsigned int is 2 to the power of n minus 1. We can substitute the value of n here. So 2 to the power of 16 minus 1. The value is 65,536 minus 1. That is 65,535. The value starts from 0 to 65,535. Therefore, the range is represented as 0 to 65,535. So the next is short int, signed shortened, and unsigned shortened. So they are also utilizing the memory space as 2 bytes, that is 16 bits to store the value. So the range calculation is similar to integer data type, which we have seen earlier. Next, long int, signed long int, and unsigned long int utilizes 4 bytes for memory space, that is 32 bits to store a value. So similarly, we can calculate the range value as we have seen earlier for int and shortened. Hope you all understood how to calculate the range values for the data types. In this example program, let's learn how to declare and assign values to type modifiers for integer data type. In this program, the statement int a is equal to 10 represents the variable a is declared as integer data type and assigned with value 10. Similarly, the variable b is declared as signed int data type and assigned with value 20. The variable c is declared as unsigned int and assigned to value 30. The variable d is declared as shortened data type and assigned with value 40. The variable e is declared as signed short data type and assigned with value 50. The variable f is declared as unsigned short and assigned with value 60. The variable g is declared as long int and assigned with value 70. The variable h is declared as signed long int and assigned with value 80. The variable I is declared as unsigned long int and assigned with value 90. So using cout statements, the values of the variables a, b, c, d, e, f, g, h, and I are displayed to the users as shown in the output. Type modifiers for character. The data type character and sign character utilizes 1 bytes of memory space. That is, it needs 8 bits to store their value. It ranges from minus 128 to 127. Next, unsigned character utilizes 1 byte of memory space. That is, it needs 8 bits to store their values. It ranges from 0 to 255. Since it is unsigned, it has only the positive values. In this example program, let's learn how to declare and assign the values for type modifiers for characters. The statement character h is equal to a within single quotes represents that the variable h is declared as character data type and assigned with value a. Since it is character data type, the value should be always given inside the single quotes. Next, the variable I is declared as signed char and assigned with value b given inside the single quotes. The variable j is declared as unsigned character and assigned with value c within the single quotes. Using cout statement, the values of h, I, and j are displayed to the user as shown in the output. Type modifiers for double. So float data type utilizes 4 bytes of memory space. That is, it needs 32 bits to store the value. And the ranges starts from 3.4 into 10 to the power of minus 38 to 3.4 into 10 to the power of 38 minus 1. Next, double data type utilizes 8 bytes of memory space. That is, it needs 64 bits to store the value. The range starts from 1.7 into 10 to the power of minus 308 to 1.7 into 10 to the power of 308 minus 1. Next, long double. It utilizes 10 bytes of memory space. That is, it needs 80 bits to store the value. The range starts from 3.4 into 10 to the power of minus 4932 to 1.1 into 10 to the power of 4932 minus 1. In this example program, let's learn how to declare and assign the values for type modifier for double. So the statement float e is equal to 3.14 defines that the variable e is declared as float data type with value 3.14. The variable f is declared as double with value 8.23.14159. The variable g is declared as long double with value 3.1415. And using cout statement, the value of the variable e, f, and g is displayed to the users as shown in the output. Let's look into the example program using size of operator. The size of operator is a unary compile time operator used to determine the size of variables, data types, and constant in bytes at compile time. It can also determine the size of classes, structures, and unions. In this example program, the class sample is created by declaring the variable x with data type int. In main function, object z is created for the class sample, and by using cout statement, the size of the class sample is displayed to the user by size of the z operator. Then, by using cout statement, the number of bytes taken up by char, int, and float is displayed to the user using size of char, size of int, and size of float operators. Then the variable a is declared with integer data type and assigned with value 5. The variable b is declared with float data type and assigned with value 7.5. Using cout statement, the number of bytes taken up by the variable a, b, and the expression a plus b is displayed to the user by size of a, size of b, and size of a plus b. And this is the output which is displayed to the user to know the bytes taken up by the variables declared inside the program. Thank you all.